That you guys could hear that in the back? Okay, so a toothbrush that plays music. In that video, imagine having somebody replace it with like death metal or porn or something like that. Sorry if you're underage. Yeah, so it was a concept, and so people are like, oh, I want to make it play whatever, but nobody ever did it. So my whole thing was like, this is a cool concept, but it needs a little bit of finesse. It needs a little bit of help. All right, yeah. So plays a 2-minute song clip of the world's most popular artists, according to somebody. Probably not in this community though. Yeah, so originally came out in 2007 and then was re-released in 2012, which is when I found out about it. What the real kind of thing is based on bone conduction, which I guess is called a dentamandibular sound transmitting system, where the element that vibrates kind of the vibrations run through your bone. You can actually hear it in like your inner ear, which is awesome. And this is dated back a long time. I was talking to Rob earlier, who just gave the talk, and he was saying something about a retainer that you could do something to play music. I had seen once like some swim goggles that had something on the back that would tell you how many laps you've run. So there's been attempts at doing consumer electronic stuff for a while in this space. And if you look at this main patent, which is the Arm & Hammer, now owned by Arm & Hammer patent, it has some references in prior art and ideas of like spoons that play music and this and that. And anything you put in your mouth will play music. There are lots of options. But the toothbrush is the one that stuck, it seems like. So here's what the packaging looked like. Yeah, it's great if you're 12, which is probably why you need help brushing your teeth anyway. But this is, interesting concept, but definitely not targeted towards people like me. And I wanted it targeted towards people like me. So, I mean, I think the toothbrush was good, but the main problem is that all the songs just totally sucked. It was lame. So the process is I'm going to replace the circuitry with something that allows me to play whatever music I want. Here's the timeline. So yeah, talking about spending lots of time on projects. This was a 5-year endeavor. And I probably spent, I don't know, maybe 12 or 20 or 40 hours on it total or something. Way more than you would expect for like hacking a toothbrush. But yeah, so I bought it right when it came out, and I was like, this is so cool. The music sucks, and I'm going to fix it. I did build a prototype in 2013, which I'll show you the pictures of. Then I moved here. Thank you. And thank you for accepting me. And everything was in boxes for a few years, and I just totally forgot about it. Like, I sort of knew in my head I wanted to do it, but it just like was not something that I could find, and I wasn't really like, I'm going to hack the toothbrush now. So I eventually found it last year and then finished it this year. So yeah, long time. That's dedication, right? Dedication to the cause of making toothbrushing better for all of you. Okay, so here's the teardown. First thing that I like to do is I get the product, take it apart, look at the circuitry, and then figure out how I can manipulate that. So normal toothbrush, looking at the top, this is all like a one-piece molded plastic, and there's some rubber built in, but it needs to be water resistant, and it's probably pretty waterproof. The batteries, which are down here, are not replaceable. I don't know how long the thing is supposed to last, but if it's a 2-minute song clip at it's 3 AAA, so it's probably going to still last a few years. Maybe with self-discharge, I don't know. I didn't do the calculations, but it will last long enough until the kids get sick of the song and throw it out or buy a new one. But there's like a O-ring around here to keep everything pretty well sealed up. So it wasn't something that I could just open up and take the stuff out. It took a little bit of kind of breaking. I broke quite a few of them, which I bought them all on eBay. And to try to figure out like how could I get the circuitry out in a way that when I put my new circuitry back in, I wouldn't break everything. And figure out how I'm going to attach to the element. So that was one tricky thing, is figuring out how to get access to this back part, which was like glued in, and there was like a post and everything. So once I got like a neat little method of like some needle nose pliers and just some finesse to pull that out, that worked okay. The other trick was getting to the element, which is here, and it's all molded in. The actual head, I don't have a picture of the head here, but it's up here. It's sort of a round thing that's not directly connected to the bristles. It's just in that housing. And the wires come down to here, and then they're heat shrinked to some wires that go down to the circuitry, which actually, so they kind of continue along here and then over to here. So I couldn't figure out any easy way to get that out without doing some modification of the area around here, which I'll show you later on. This plastic piece you see here, if you pull that out, it's this plastic house, this little carrier here, which has the space for the batteries. So now that I know how to open this, I can replace the batteries, which is good. This is the circuitry here, which there's some discretes. There's nothing on the back side, and so there's the button to start and stop the playback. You can play the song and it will continue to play all the way through, or you can stop it if you're done early, which is cheating because you're supposed to brush your teeth for 2 minutes, right? But who actually brushes their teeth for 2 minutes? Really? Oh, shit, okay. I have a dentist appointment on Wednesday, so maybe I should start. Yeah, I always say I do, and they know I'm lying. I didn't realize that people actually do. Good for you guys. That's amazing. Okay, so don't come close to me, I guess. So this is the main circuit that was here. So yeah, the button here, and then this is a chip-on-board type of device. So if you think about like a normal integrated circuit that you see on a circuit board, it's like a black plastic housing with wires with leads coming off, or maybe there's leads underneath. You can't see them. This is the silicon underneath here, actually an integrated circuit, or just the chip, wire bonded with little tiny wires to the circuit board, and then coated with epoxy on top, blobbed with epoxy. This is like a really hard coating that if you want to manipulate devices like this, you could either get the coating off with chemicals or scrape it, or more likely just look for other places to tap onto it. So it's a possibility that, I could maybe monitor some stuff here and see, but it's really just looking for the button press. All the song stuff is stored in here. And this stuff, the chip on board is really common for high volume, low cost stuff where things aren't going to change at all. But I wanted to be able to change the music and have control of the music. So my whole thing was like, all right, just get rid of this, build something that looks exactly like that can take an SD card that will play songs. I don't like recreating the wheel, and I like being able to share my projects so other people can build on them. And in the same way, I don't mind using other people's projects to build on my stuff. So this just happened to be, I did some Google searching of like audio player wave file microcontroller. Because I didn't want to have to design the whole SD card interface, the FAT file system, all of that. So this person named Chan, I don't know much about that person because there's not a lot of information, but there's tons of great projects on the website. And this was one of like this project that he or she came up with that was a tiny wave player for an 8-bit AT-Tiny AVR, Atmel AVR microcontroller that also had support already for the FAT file system, so it would read a memory card and play the song. So it was great. That was like a perfect starting point because I didn't have to do like all this crazy reverse engineering or crazy engineering to get this stuff done. So this was the starting point for the project. Let's see. So yeah, he has or she has a bunch of code in here to bit bang through over SPI. So software SPI control to read the SD card, which is a standard kind of SPI interface. And then there's some module FATFS that people have been using. I think it's for Atmels. I'm not exactly sure, but it's some C library. So, FATFS is that generic library? What's that? Oh, okay, cool. Yeah, so that's the standard. So he wrote or she wrote a petite FATFS, which is just sort of a carved out version to for what's going to fit with this particular microcontroller. So less than 512 bytes of RAM, which is cool. So if you take nothing else out of this, if you ever want to play WAV files from a microcontroller over an SD card, just use this stuff. Yeah, so standard WAV format in RIF, 8 or 16-bit files, and then it's mono. So yeah, all that starting point was there. So I built up a prototype and just had it working without the toothbrush, right? So AT-Tiny microcontroller, little circuit, and SD card with a little carrier board from L0pht over to a speaker, and it worked fine as expected, right? Because that part of the project already worked. I did have to make some firmware changes to get the code to compile because the last time it was worked on was between 2009 and 2012, so I had to get some stuff, tweak some stuff to get it working to compile in 2017, but that was not too much of a problem. But yeah, so build the prototype up, and this is again part of the standard process for me anyway. Is when I'm starting to design a circuit, I will do something on a breadboard like this where you can plug stuff in, take things out, change values, get everything working here before you kind of hard, code it into circuitry on a circuit board. So that worked. So then I went and built my first version of the board, which doesn't get a lot of respect in this presentation because it didn't totally work the way I wanted it to. But I will mention, so I got the board back through Osh Park, of course, because they're awesome and local, and here in the front row. So yeah, got the boards back, built it up just like the prototype, and which was just like the version that Chan had written or had made. But it turns out when I hooked it up to the actual element, it was way not loud enough. And I had actually tested that with the prototype at the beginning, but it just didn't occur to me that it wasn't loud enough. I heard it, and I'm like, yes, it works. But then I didn't test it as much as I should have before I built the first version. So I built it and realized it wasn't loud enough, and I tried to convince myself that it would be okay. I was like, well, I can kind of hear it as long as there's nothing else going on around, but I just couldn't bring myself to actually call that complete. And I was like, damn, now I have to go and find an amplifier and build another circuit and hack on that and try to get it a little better. What I ended up doing is using a little level meter to measure the sound of the original and then try to match it a little bit to see, okay, let's add my amplifier and see if I can jack up the volume and make it work. Because with the speaker, with my amplifier, it was really loud. But then with the transducer, it wasn't, because however the construction of that thing is and the resistance, and I don't even know. So I figured I would just do some tests. Once I got it close enough, I ended up using a LM4864, which I'll show you on the next slide, just a standard kind of audio amplifier to take the output of Chan's design and then amplify that. So here's the final look of the circuitry. Fits right in place. So yeah, button, micro SD card slot. Let's see, battery, transducer, and then the backside had the microcontroller, the amplifier, and an on-off control, which I'll talk about when I show you the schematic, and then the voltage regulator. So power comes in, goes to the voltage regulator, gets regulated down from the 4.5 volts to 3 volts to power everything. Microcontroller has the code. The on-off control, again, I'll talk about later. And then the amplifier takes the sound in, amplifies it, and then sends it out to the transducer. And it just so happened that the board I'd already designed, for the first version, it looked exactly the same, except without the amplifier. There was nothing under here. I might have had a big bypass capacitor or decoupling cap or something over here. So it just happened that this was just the right size. So, I didn't want to have to go to smaller components or anything like that. So here's the final schematic. Sort of, assume Chan's design is this, and then I have kind of the simple stuff added to it. So yeah, SD card goes in here with the wave file, gets communicated over SPI to here, and then this will output PWM to the audio amplifier, which will amplify it and then play the sound. A cool thing is down here, we have the voltage regulator here, and then remember at the beginning I mentioned you can play the song, but you can also stop the song halfway through for people like me who don't brush their teeth for 2 minutes. I needed a way to do that, sort of have on-off control of the system. And there are ways that I had thought about using transistors. You could have two transistors and do some stuff with discrete components, but that would have been way too big to fit on the board. It turns out that Maxim has a chip, this 16054, which is an actual on-off controller. So typically the setup is you have your on-off controller with an input on a button, and then the output and the inverted outputs you can choose, depending on your system, feed that directly into the enable pin of the low dropout linear regulator. A lot of designs, normally the enable pin is just pulled high, so it's always on. So this is an actual use of the enable pin. So now you can push the button. This will always stay on. This has a pretty wide voltage range, so you power it directly from the batteries. And this will always stay on, and I think it sucks 7 microamps or something. It's small enough for most battery-powered systems, and it will eventually kill the batteries over time, but I thought it was a good compromise. So it stays on, waits for an interrupt, and then we'll set the output. We'll toggle the output. So when I want to interrupt the playback, I can push the button again. It's going to change the state of that, disable the voltage regulator, and turn it off. All right, so that's cool. What I also did is modified the firmware to change one of the pins. So there's a reset pin normally that with this chip, this ATtiny 85, the reset pin is by default a reset pin. I disabled that, changed the fuses to turn it into a GPIO pin, and then modified the code. So once the song stops playing, the way it turns itself off is it will set this pin high. Normally it's low. Set the pin high, which clears sort of as a secondary input into this part, and then toggles the output. So it will shut itself off. So now the user can manually turn off the unit, and then the electronics can manually turn itself off also, which I thought was sort of cool. And then the amplifier, bridge tie load output, and it's pretty loud. With a normal speaker, but not with this. but louder than it was before the amplifier. So yeah, just a list of some of the code changes. This stuff's all on, where did I put that code? I think there's a link to it on my website. I think it's on my website. I don't know. But you can see the code modifications on there. But yeah, so fix some of the stuff that wasn't working. The way that Chan's code was is it would play every single file in the directory like one time, and then it would keep repeating it. No, yeah, it would play each one time and then repeat and keep playing, sort of, constant stream. So I just changed that to just play the first file it found on the file system and play it once and then turn itself off. And then dealing with problems of that, because when you disable the reset pin, that prevents you from doing any subsequent in-circuit programming. So you can only program it in, I think it's the high voltage programming mode or something, and I had to use a device programmer to do that instead of like the standard way of the whatever the L0pht the USB tiny ISP stuff, sort of in-circuit serial programming. So it was a little bit of a problem when I was modifying the code and then testing the code, because I couldn't just do the typical iteration of make code changes, program it, test it. It was like make code changes, put it in the device programmer, program it, stick it in the device, socket, and go from there. It was just a longer process. But luckily the changes weren't like that crazy. But if you wanted, compile your own, grab the code, use these things with these few settings, and you should be good to go. So here are some of the pictures of the final board. Now that I knew that board worked, again, I want to make it look as stock as possible, but I just couldn't figure out a good way to get into that transducer. So I took a little drill, drilled in, used some dental tools to like fish out the wires. So cut them with one dental tool, and then use another one to fish out the wires, and just left enough that I could strip it off, add some, blue wire, 30 gauge wire. Yeah, it was like laparoscopic without a camera, right? So you're just sort of guessing. And maybe I could do a smaller hole with better tools or something, but that was fine. What I didn't end up doing is putting like, silicone in here, and I probably could if I was actually going to use it, but after all this work, I didn't want to use it because it's like, I only had the one that actually works well and looks good, and I was like, I just won't brush my teeth. Yeah, so this is what it looks like. So final thing, circuitry, the transducer gets extended out to here, and then SD card here, slides it in, put the batteries in, and that's it. So with that, let's give our demonstration. So I released a video about this online, I don't remember when, a few months ago or something. And the original intent, so I grew up in sort of the kind of punk hardcore scene in Boston, and listened to a lot of straight edge hardcore, so kind of positive message and drug free and all this stuff. And there was a band called Crucial Youth that had a song, which was a spoof of like a lot of the positive bands of the time. And they had a song called Positive Dental Outlook, which I thought would be like totally fitting for this toothbrush. Because there's a lot of songs about positive mental attitude, and being positive. So I thought that would be funny. So I made a video and showed that song, and realized pretty quickly that like most people didn't know what that was and could barely understand it because it was loud and fast and everything. So when I got accepted to B-Sides, which thank you to everybody who accepted me, because I wasn't expecting to give a talk on hacking a toothbrush, and to Chris and Steph for convincing me to also submit it. I figured I should do something more Portland-based, right? Because we're in Portland, and it would be pretty silly to just play the same song. So I have a special song for you that nobody has heard yet, and well, at least not in toothbrush form. And I'm pretty proud of it. I think it's pretty hilarious, and hopefully somebody will recognize it. Let's see. So how am I gonna do this? All right. So I'm gonna put this microphone over here, and I should mention. So I have two different speakers, because if I just held the transducer to here, you're probably not going to hear it. So I have the paper cup, which were a wax-coated paper cup, which works pretty well. And then there's this kind of metal Mancala box, which this sounds a little bit tinny, but this is what I use for the other videos. I think I'm going to try it with the cup first, and we'll see if you can hear it. I have a backup video just in case, anyway. But let's see what happens. I don't know how I'm going to. Yeah, let's see. Yeah, just hold this so it doesn't wiggle. So let's see. Will you be able to hear that? Yeah. Okay. I think I'm going to sit so I don't wiggle around too much and dance. All right, so I might have to do this a few times. I don't know. Let's see if you can hear it. Ready? Go count down. 3, 2, 1. minute and a half. What's that? Yeah, we'll try the 10. Here, you gotta hold it down a little bit. Oh, I can do it. It eventually stops.
Why do you go like a pickup song? Sell your CDs.
You can put a bird on something and call it art. Hey, I made it.
Yeah, you're a little late.
Sorry.
You're also a little San Francisco right now. Sorry. Much better. Welcome to Portland.
Thank you.
Yes. That's now officially my favorite song. And I've listened to it like 1,000 times as I was getting the volume right and everything. And that was actually the remix. So if you watch the first episode of Portlandia, that's where this tune came from. And this was the remix version. So somebody took it and made it sound even better. So yeah, that's one thing you have to do is you're gonna have to fine tune your audio for the transducer because it just has a much weirder response. But yeah, then you can have awesome songs like that. So possible enhancements, I think none. I think it's fine the way it is. But of course, people have opinions. So when I originally posted the video, they're like, well, you have Bluetooth and you can play it from your phone. It's like, because I don't want to have my phone in the bathroom when I'm brushing my teeth for less than 2 minutes anyway. So I don't know. And then inductive charging, maybe so you don't have to change the batteries. And then actually, the one thing I would say is some easy access to the SD card, because getting to it, you have to unscrew the screw on the back of the, where the batteries are, pull that out, pull the housing out, and then change it. So that's sort of a pain, especially for testing. But works fine for my purposes of giving a talk and putting it in a box. Okay, so final slide. Yeah, if you want to build your own, everything's on my website. And you can go directly to Osh Park if you want to order the bare boards. I have them shared, so you can just go there, order them, get your toothbrush, and have better sounds. So with that, yeah, thank you, and remember to keep that positive dental outlook. And this, by the way, was another inspiration. This is called the youth brush, because it's like for the youth of today. Yeah, so thank you. Oh, do we have any questions? No time. You're not allowed to ask questions. But I'll be outside if you have any.